Good morning, class.
Good morning, ma'am.
How are we?
We are good. How are you, ma'am?
I'm good, thanks. Today, we are going to talk about indices. And by the end of this lesson, you guys are expected to be able to interpret and use the law of indices, including positive, negative, fractional, and zero indices. You should also be able to simplify expressions involving indices. Example, like the expression given here. You should also be able to use indices to solve exponential equation, like the one example given here. Any expression written as a n is defined as a variable a raised to the power of the number n. And n is called a power, or we can call it an exponent of a, or we can also call it an index. From grade 9, we spoke about the index of a number. Can someone tell me what an index of a number is? Matthias?
An index of a number is how many times you multiply by the index.
Okay. Okay, you are right. An index of a number is how many times to use the number in a multiplication. For example, here, where n is a positive whole number, we raise a to power 1 and we get a 1, whereby we raise a to power 2, we multiply that a with 2, like we multiply twice, and when we raise a base to power 3, we multiply that number 3 times, and when we raise it to a positive whole number, let's say a big positive whole number, we multiply that number with that positive whole number. Moving on, indices satisfy the following rules. Where n is a positive whole number, we raise that a to power n and we multiply it with that number. For example, if we have a base 2 raised to power 3, we multiply that 2 3 times, then we'll get 8. And in number 2, we have negative powers. We raise a raised to power and minus n, and we get an expression of 1 over a raised to power n. And for example, here we have a raised to power minus 2, then we'll get an expression of 1 over a raised to power 2. Are we together?
Yes, ma'am.
All right. Moving on. When we have our base, which is a equal to, then if we raise it to power negative 1, we get something like half. And when our 2 is raised to power minus 2, we get an expression of 1 over 2 raised to power 2, which we can also write it as 2 times 2. Then we'll get 1 over 4. And in number 3, we have is a 0 power. Here, if we raise anything to power 0, we always get 1. For example, if we raise 8 to power 0, then we get 1. And if we also raise 100 to power 0, we'll still get 1. However, when we raise a 0 to a 0, we get a 0. Anything like 0 raised to anything is always 0. Okay, and in number 4, we have a fractional power. When we raise something to a fraction, we get an expression of square root of that thing of A. Then, in number, for example, 9 raised to power 1 over 2, 9 raised to power 1 over 2, we get a square root of 2, square root of 9, and we get square root of 9, which is equal to 3. And when we have 8 raised to power 1 over 3, we get a cube root of 8, which is equal to 2. And all indices satisfy the following rules in mathematical applications. And in rule number 1, if multiplication is given, add the index of the same base. Since we have the same base, which is A, we just add the index or the exponent together. Then we'll get something like A raised to power M plus N. For example, we have 2 here, which is a base. We have same base, which is 2. Then we add 2 with 3 to get 5. Then we get something like 32. In rule number 2, we have this. If division is given, we add the index of the same base. We add M and N. We subtract, not add. We subtract. Then A raised to power M divided by A raised to power N. Then we get something like A, M minus N. For example, 2 raised to power 3 over 2 raised to power 2. We get something like 2 raised to power 3 minus 2, which will give us 2 raised to power 1. Then we'll get a 2. Okay, moving on. We should note this. If M is equal to N, if the index are the same, we subtract those index, then we'll get a power of 0 to get a 1. And we also need to note when one of the power, it's a negative, which is in a denominator, then that will become a positive. Then we'll get something like A raised to power M plus N. We also have to note if our index is a negative on the numerator, we still have to subtract because it's division. Then we get something like A raised to power minus M minus N, which will give us an expression of 1 over A M raised to power M plus N. And in rule number 3, we have, if we have a base raised to something and it's also multiplied to something, it's also raised to a power outside the brackets, then we multiply those indexes. So we get A raised to power M times N. For example, we have 2 here raised to power 3, then we multiply it with, we raise it to power 2 to get 2 or 2 raised to power 6, then we'll get a 64. Okay. Then in rule number 4, we have if bases are different, then and the index are the same, we multiply the bases and we raise it just to a single power, which is N. For example, we multiply 3 with 4, then we raise it to power 2 since the exponent or the powers are the same. To get something like 12 raised to power 2, then we'll get 144. Are we together, guys?
Yes, miss.
Menti, are we together? Okay.
Yes, miss.
Okay. Let's continue. Likewise, if we have division and the index is the same, we still raise that base of a fraction to that same index. But this can only be done if the denominator is not equal to 0, because we do not divide anything to 0. For example, if we have 6/2 divided by 6 raised to 2 divided by 3 raised to 2, then you get something like 6/3 raised to power 2, which will give us 2 raised to power 2, which is equal to 4. Then here we need to use indices to solve an exponential equations. Here we are only trying to express this in like we have to write both expression, we have to write it like to get the same base. Then we express it like that, we get 2 raised to power 3, then here is 2 raised to power 2. Then the bases cancels out, then we are only left with powers. Then we try to solve for x, then we get x is -1/2. Okay. Here is a homework I would love you guys to go do at home. Then you bring it in tomorrow. I also have prepared for you some reading materials. You should consult your mathematics textbook, which is y equal mx plus c. And you should also go on that link. You'll find notes on indices. We came to the end of our class, and if there is any questions, you guys are welcome to ask. Is there any questions?
No, ma'am, we are all fine. I'm good. I have no questions.
Okay. Thank you, and see you on Monday.